Good morning, students. Our next topic is equipotential surface or lines. The topic here means that for any particular surface or lines, the V value is constant. Such surfaces or lines are called as equipotential surfaces or lines. So the simple definition for this topic is every point lying on those surface or lines is at same potential. The major importance of this particular concept is the density of equipotential lines gives an idea about the magnitude of electric field. If the equipotential surface, so that if I say this is one equipotential surface, so here these equipotential surfaces are closed, so the electric field here is higher. Whereas this particular line compared with the other three lines, the space between them is more. Then in that case, the electric field intensity starts decreasing. So therefore, it is having less electric field strength. That's why I have given here a point. A higher the density of equipotential surface or lines, larger the field strength. Next point is direction of electric field is perpendicular to the equipotential surfaces or lines. So as you can see here, I have taken a point charge. The electric field from the point charge is spherically symmetric, so they are radially pointing outward. Then in this case, the equipotential surface is a family of concentric spheres, that is spherical shells. So this is one equipotential surface and second equipotential surface, and every point you can see that the electric field is normal to the surface. Okay, so for a point charge or spherically charged distribution, that is the charge filled on a spherical surface, they will have family of concentric spheres as the equipotential surface. Since this is a two-dimensional diagram, you can see it as circle, but in 3D they are shells. Okay. Next, students, for uniform field, what is an uniform field? Uniform field is nothing but we learned that electric field value is constant everywhere. How do you define uniform electric field? They are equally spaced and same direction. Okay, same direction. Then we call such a field as uniform electric field. For uniform electric field, the equipotential surfaces are family of plane. So this is one plane. So it is a two dimension, you are seeing it as a line, but in three dimension it is a plane. And this is another plane, third plane, fourth plane. And each point the potential values are denoted accordingly. Here you can see for the first equipotential surface it is denoted by V1 and following V2. Similarly V1, V2, V3, V4. The very important relation is here. The potential of V1 is greater than V2 in case of a positive charge. Similarly, in this case, V1 is greater than V2 is greater than V3 is greater than V4. And how do you able to remember this is, we will actually, I understand the idea that this particular potential value will be positive in case of positive charge and negative in case of negative charge. So along the direction of the electric field, the potential decreases, and hopefully students, you remember the topic was named as the potential gradient, which is our next task to do it, where in that concept I will explain you in detail. Now the questions that are generally asked are, a metallic surface of any shape, remember any shape, is an equipotential surface. So here you can see one spherical in shape and in irregular shape. the charges generally reside only on its surface for conductors. So this entire surface will act as the equipotential surface. Similarly here, though it is irregular in shape, that particular surface will act as equipotential surface. A property of equipotential surfaces or lines is they do not or cannot intersect. And these are like 2-mark questions. If you take a pair of charges, that is like equal and opposite or equal and similar charges, you are asked to draw the equipotential surface. So this particular thing you can take it as assignment and try to understand why the lines are closer at some points and the lines are, that is the equipotential surfaces are wider away. And in this understanding you will come to know that this configuration is very important. So do for both 2 equal and opposite charges as well as 2 equal and similar charges. And we haven't started a law that I was mentioning about it, that's like named as Gauss law. So if at all they ask you for 1 coulomb of charge, so number of lines originating from a unit charge is 1 by epsilon naught. Okay, so number of lines is generally denoted by the symbol phi, phi, phi. Okay, this phi is giving, also named as electric flux. So electric flux is nothing but number of lines crossing a particular surface area. Okay, so in that case the number of lines simply originating from a unit charge is given by 1 by epsilon naught. Always keep that in your brain. Okay, so we will try to do some questions based on the topic we learned now. So this is an IIT question which is also important in CBSE. So here there is one metallic sphere, as you can see it, and they have given you a 4 electric field lines, namely 1, 2, 3, 4. Out of, amongst 4, which one is correct? So if you see, the property of electric field line is that the electric field lines cannot pass through the metallic conductor. Then in that case, simply the number 2 and number 3 are wrong. Okay, and one more thing we learned now, that a metallic surface will act as a equipotential surface. Then immediately we know that this particular surface is an equipotential surface. Therefore the field lines need to be normal toward, and if you will see it, this is the surface and the magnetic field, the electric field line is passing here or incident at this point, which is not normal. So therefore the line 1 is also wrong. Only in the case of 4 it is normal to the surface and emerging out normal. So option 4 is correct. Okay, and this is a little bit tricky question which is also a CBSE question. You can see here the field lines are closer at the point A and C respectively, and they are separated away at point B. Now having this diagram, they are giving you option that first option EA at point A is greater than EB greater than EC, EA equal to EB equal to EC, EA equal to EC, which they are greater than EB, EA equal to EC less than EB. Okay, so how do we answer this question? So particularly point A and point B, if you see, they resemble that the spacing between the lines are same. So it gives a hint that EA and EC, they both need to be equal. comparing in this, option C and option D have this particular terms EA equal to EC. And how do you say which one is correct? With the knowledge that higher the density, larger the field strength. So here the field lines are wide away. So that means that it's having less electric field in this particular region, that is point B. So it clearly tells that EA equal to EC is strictly greater than EB. Hoping that was clear to you. Okay. So okay students, read this topic once again, make a notes of it and please send it to me so that I can understand you, like what is your how much you are thorough with it, and I will be posting you questions soon. Thank you.